Multiplying binomials. So first, some terminology. So we're going to review some definitions. So a polynomial is an algebraic expression. And it's an algebraic expression that is made up of one or more terms. And the terms are separated by either addition or subtraction signs. So some examples of a polynomial could be 2x squared plus 3xy plus y squared plus 3. So what is a monomial? So a monomial is a polynomial, but it only has one term. So an example of a polynomial or a monomial could be 5x. It might be 3x squared. It could be xy. It could be just -2. It could be just a y squared. Any of those are monomial. So there's only one term. So there's no addition or subtraction signs between them like they were in the polynomial. So what is a binomial? Well, a binomial is, again, another polynomial. But this time, like the prefix bi sort of triggers you, like bicycle, has two terms. So an example of a binomial could be 2y squared plus 3. Another one might be -3 plus 4x. You could even have one that has the same letter. So it could be like -b squared plus b. So each of these have two terms. So they're separated by an addition sign. You could also have ones that are separated by a subtraction sign. Like you might have like x squared take away 4, right? So that's an option as well. So a binomial is a polynomial with two terms. So what does a trinomial mean? So if monomial is 1, like a monocle, binomial is 2, like a bicycle, a trinomial is 3. So it's a polynomial that has 3 terms. And you can add the letter S to these ones. So some examples of a polynomial that is actually a trinomial could be 2x squared minus 3x plus 4. Another example might be -x squared plus 2x plus 1, and any other variations. So this is a polynomial with 3 terms, so 3 terms separated by addition or subtraction signs. So let's just quickly identify whether each of these polynomial expressions are a monomial, binomial, or trinomial. So this one has 2 terms, so this is a binomial. 7 is just 1 term, so that's a monomial. This is 2 terms, so this is also a binomial. 1, 2, 3 terms, so that's a trinomial. This one is just 1 term, so it's a monomial. And the last one, 1, 2 terms, so it's a binomial. So you're looking for those addition or subtraction signs and thinking about how many terms are there in that expression. So when we want to multiply binomials, so binomials are 2 terms. So it could be, for example, x plus 3 times x plus 2. This would be an example of multiplying 2 binomials. So we have 2 binomials, we put them in brackets, and we're going to try to multiply them out together. So in order to multiply binomials, we need to use the FOIL method. So what does FOIL stand for? Well, FOIL is an acronym that helps us remember to multiply every term by itself. So we have to multiply our first terms together. So in this case, it would be our x and the x. The O stands for the outside terms. So in this case, it would be the x and the 2, so the ones on the very outside of those brackets. So x times 2. The I stands for the inside terms, so the ones right in the middle. So in this case, it would be 3 times x. And then the L stands for the last term, so the last terms in each bracket. So 3 times 2. So we're going to use this exact example to, except my order is different, to do this first example. So sometimes it's helpful to draw the lines if that's something that works for you. What is the first two terms? Well, that's x times x. So x times x is x squared. I'm just going to write it over here. Then we do the outside terms. So x times 3. So x times 3 is the same as 3x. Then we do the inside term. So 2 times x is 2x. And lastly, 2 times 3, which is positive 6. So sometimes it helps to draw, so we're multiplying the first term in the bracket by every term in the second bracket, and the second term in the first bracket by everything in the second bracket. So once you've used FOIL, so you're going to have 4 terms, now we want to simplify or collect those 2 middle terms. So this simplifies to x squared, and then 3x plus 2x is 5x, and then plus 6. So step number 1 is to use the FOIL. I've actually done all of the steps in one. So this would be step number 1. So this is step number 1, and this is step number 2. So step number 2 is to collect the terms and simplify. So I wonder if I can move just this section. No. So this is step 2. So right here, I could go ahead and write that down there. So this becomes my x squared plus 5x plus 6. So let's go through another example. So example number 2, remember I've included those steps for you here, so you can refer to those. So we want to first use FOIL and then collect the terms and simplify. So 3x times 2x. 3 times 2 is 6, and x times x is x squared. Then 3 times 5, 3x times 5. 3 times 5 is 15x. And then we do 2 times 2x, which is negative 4x, and 2 times 5, negative 2, times 5, which is negative 10. So first, outside, inside, last. So now we simplify these 2 middle terms. So we have 6x squared plus 15x take away 4x is 11x, and then take away 10. So let's go through a couple more examples. Example number 3. So our first 2 terms, m times m is m squared. So this is f. Our outside terms, m times 2 is plus 2m. Our inside terms, there's our I. Negative 8 times m is negative 8m. And our last terms, negative 8 times positive 2 is negative 16. So let's simplify or collect our middle terms. We have m squared. 2 take away 8 is negative 6m, and then negative 16. And the last example that we're going to do on this sheet before we get into some word problems or applications is example 4. So first terms, a times a is a squared. Outside terms, a times negative 9 is negative 9a. Inside terms, negative 3 times a is negative 3a. And last terms, negative 3 times negative 9 is positive 27. So let's collect our middle terms. A squared, negative 9 take away 3 is negative 12a plus 27. So you can think about using the acronym FOIL, or just remembering that we need to multiply each term in the first bracket or in the first binomial by every term in the second binomial. So let's go through a couple of application questions. So a swimming pool has the dimensions that the length is 2x plus 1 and the width is 3x minus 3. So you can draw your swimming pool if you'd like to. So the length is 2x plus 1, the width is 3x minus 3. So if it helps you to see that visually, by all means go ahead. So we want to determine an expression for the area. So remember, the area of a rectangle is length times width. In our case, it's going to be, instead of L, we're going to write 2x plus 1. And instead of width, or instead of W, we're going to write 3x minus 3. So now this becomes a question where I can multiply binomials, so use FOIL. So my first two terms, 2x times 3x is 6x squared. 2 times 3 is 6, and x times x is x squared. 2x times negative 3, so the outside terms, is negative 6x. So 2 times negative 3 is negative 6, and then the x. My inside terms, 1 times negative 3x is 3x. So 1 times 3 is 3, and then the x. And then my last terms, 1 times negative 1 is negative 3. So I need to simplify, so I need to collect my middle terms. So I have 6x squared. Negative 6 plus 3 is negative 3x, and then minus 3. So now I have a simplified expression for the area of this swimming pool. So what happens if the value of x is now 10 meters? So what would the actual area be? Well, I'm going to use my simplified expression, and I'm going to substitute the value of 10 in for each of those x's. So the area is going to be 6 times 10 squared minus 3 times 10, take away 3. So I'm going to follow BEDMAS. So 6 times 10 squared, which is 100, so 10 times 10. Negative 3 times 10 is negative 30, and then take away 3. 6 times 100 is 600. Negative 30 take away 3 is negative 33. And 600 take away 33 is 567. And my units, because it told me meters, is meters, and because its area is meters squared. So I could write some therefore statements. So therefore, the area of the pool is 567 meters squared. I could have also written a therefore statement for part A. So therefore, the expression for the area is 6x squared minus 3x minus 3. So we can actually solve some questions involving multiplying binomials that have more of a real-world application to them. So if you have any questions about multiplying binomials, please put them in the appropriate discussion post, board post, or send me an email.